Hello everyone, Mr. Chen here. So please take your packet out and turn to the section where we were at yesterday about adding and subtracting rational expressions. Yesterday, we were focused on examples where the base was the same. So all we had to do was just add straight through, sometimes do some factoring. Today, we're going to look at examples where they have unlike bases and how to deal with them. So let me go ahead and focus on the unlike base part. We're looking at number 7. So for number 7, when we are looking at the problem, we notice that the denominator is different. One is 2x, one is 3x. So what we have to do first is identify what is the common denominator. The common denominator here is going to be something with 2 times 3, which will give you 6. And they both have an x already. So therefore, it's going to be 6x. And now we have to take into account, what does it take to change 2x to 6x? If you said times 3, then you're correct. Therefore, we have to multiply the denominator by 3 and the numerator by 3. On the other hand, we have to ask ourselves, what does it take to change that 3x to become 3x to become 6x? And if you said times 2, you'd be correct. But then we gotta multiply the numerator also by 2. As a result, 3 times 15 gives you 45. And then we have minus, and 16 times 2 gives you 32. And now we just simplify, and we should get 13 over 6x, and that is our correct answer. Please feel free to pause the video at any time to rewatch or to write something down, and then continue when you're ready. I will also ask you to pause the video to try something yourself first, and then and then press start to watch the solution and check your answer against mine. Looking at number 8 now. Once again, we have different denominators. One's a squared, one is 8a. So therefore, I have to find a new common denominator. The common denominator here, I see there is a 1 in front there, and 8. 1 times a is 8. So I know that the coefficient should be an 8. And then I also see that I have a squared, 2a squared, and a. So then the most common one they can multiply to is a squared. So now what I gotta do is find out what's common. Sorry, I have to find out what I need to multiply each term by to become 8a squared. On the left hand side, the term on the left, it's missing an 8. So multiply the denominator by 8 and the numerator by 8. On the right hand side, I notice that it's missing an a, so multiply the denominator by a and the numerator by a. Now we just go ahead and simplify. 8 times 4a is 32a. Minus 7 times a is 7a. All together, that will equal to 25a all over 8a squared. We're not done though. We have to make sure we simplify. So 25 divided by 8, we can't do that. Nothing to simplify there. But I have 1a in the numerator, 2a in the denominator. So after I cancel, my final answer should be 25 all over 8a. Go ahead and turn the page. So we are now looking at the backside. Let's go ahead and tackle number 9 real quick. So looking at number 9 here, just like before when you were simplifying rational expressions, you should be looking at the denominator, obviously, because we need to have common denominators. But you should notice that this 5k minus 10, your mind should go, oh, I noticed something about 5 and 10. I can factor out GCFs. And yes, you should definitely factor out the GCF, because it's going to help us identify what the common denominator will be a little bit easier. So I'm just going to rewrite the problem. I have k squared plus 16. But I'm going to factor the denominator to become 5. Because 5 and 10 have a GCF of 5. 5k minus 2. And then write the right side exactly the same. So now take a second, ask yourself this question. What is the common denominator? If you said 5k minus 2, you would be correct. And therefore, what do we need to do to make the denominator on the right the same as the left, which was the common denominator? Yeah, just multiply by 5. So we just, in this problem, we only have to multiply the right side by 5. I'm just going to go ahead and do the problem without as much talking. So then we get k squared plus 16 minus 20. Simplify, we get k squared minus 4 all over 5 divided by k minus 2. If you stopped here, something is wrong. You can simplify more. Why can you simplify more? Yes, if you looked at this numerator and you said difference of squares, you'd be correct, because 4 is 2 squared. So a squared minus b squared equals a minus b, a plus b. So you should have factored some more and got k plus 2 times k minus 2, all divided by 5 parentheses k minus 2. And of course, now the key idea, we can divide the k minus 2's to become 1's. And our final answer is k plus 2 all over 5. Right now, I invite you to try attempt number 12. Go ahead and pause the video, try it yourself, and then we'll come back to, and then restart the video when we're ready to go over it, okay? Alright, so Mr. Chen is back from cyberspace. Here we go. So I'm doing number 12. Hopefully your first step here was to factor. As you saw the trinomial in the numerator, and then the difference of squares in the denominator. So you should need 2 types of factoring. So I'm doing the numerator first. M times m is m squared. And it should be 3 and 2, because 3 times 2 is 6, and 3 plus 2 is 5. So in the numerator, it becomes m plus 3 parentheses m plus 2. In the denominator, we just did that type of problem. We know that this is a squared minus b squared. So the denominator should become m plus 2 and minus 2. Plus the right side, 2 over m minus 2. And before you do anything else, you should always try to simplify first if you can. Take a look here. Right? Yes, I see the m plus 2 in the numerator and denominator. I can divide them and they become a number 1. So if you saw that, just go ahead and cancel them out. Sorry, divide them, not cancel them out. Divide them. They become 1. And all of a sudden, if you look at the new expression here, I have m plus 3 divided by m minus 2 plus 2 divided by m minus 2. We have common denominators here. They're the same. So we don't have to do any more calculation other than add. So we just have to add m plus 3 plus 2 because they have the same denominator. Let's add them, and we get m plus 5 all over m minus 2. And we're done. So the best one for this problem is make sure you factor when you can, simplify by dividing when necessary, and then look for your common denominators if you need to. In this case, you didn't, but sometimes you will have to. All right, we're going to do one last one together. Let's take a look at number 15. Go ahead, pause the video, try yourself, restart the video when you're ready to go over it. All right, we're back. So, once again, I'm looking at denominators. I'm like, okay, I need to factor these. So, looking at the left side of the expression, the 2 stays the same. I know I can factor over 4. So, it becomes p minus 5 plus p minus 6. I got to do my big X on the right. P times p squared. That is what? Negative 5, negative 3? Yeah. Negative 5 times negative 3 is 15. Negative 5 plus negative 3 is negative 8. So I have p minus 5, p minus 3. Now I gotta figure out my common denominator. So we have one big common denominator here. And notice that I have a 4, I have a p minus 5, a p minus 5, a p minus 3. So I actually have 3 different terms, huh? 4, 1, p minus 5, 2, p minus 3, 3. So my common denominator is going to be the multiplication of this term times that term. So it'll be 3 pieces. 4, p minus 5, p minus 3. That is your common denominator. Because that's what all these 3 terms can multiply to. So now we can look at this problem and go, okay, what should we do now? Let's identify. So we can see that on the left side here, it has 4 and p minus 5. 4 and p minus 5. It's missing the p minus 3. So therefore, I gotta multiply this term here by p minus 3. The numerator by p minus 3. Looking at the second term, it has a p minus 3 and p minus 3. P minus 5 and p minus 3, it's missing the 4. So I got to multiply the numerator and denominator by 4. Times 4. Oops, sorry. Why did I do that? That's weird. Oh, there we go. Times 4. And then times this also by 4. So I'm going to rewrite the expression a little nicer. So I have 2 times p minus 3 over here. Plus is right there. Plus 4 parentheses p minus 6. Right now it's a little bit messy. Let's make sure we do the work and we simplify and we should be good. So I distribute 2p minus 6. 4p times negative 6 plus 4p. 4 times negative 6, negative 24. All over that mess in the denominator. Let's see if it gets nicer as we simplify more and more. So then 2p and 6p, 4p makes 6p, negative 6, negative 4, together make negative 30. Still all over that mess. Oh man, my own handwriting is tricking me. This is 5 right there. Sorry about that. You should be like, oh, I can factor. So the numerator should become 6p minus 5 all over 4, p minus 5, p minus 3. Let's go into dividing. P minus 5, p minus 5 become 1. I can divide the 6 and 4 both by 2. So my final answer should be 3 on top, numerator, times 2 times p minus 3 in denominator. And this will be your final answer. So, those are the examples we just gone over. Please go ahead and try the other problems by yourself. Your homework's all the odds. Check answers on Google Classroom. And please be ready with questions when I come back and see you on Thursday. Mr. Chen, out.